Welcome back. Problem 12.17. So statement is determine the elastic curve in term of x1 and x2 coordinates. What is the deflection of and C of the shaft EI is constant. So you can see this is the shaft AC having support at point A and point B, and there is movement m0 is given at point C. So we have two coordinates, one is x1 in this direction, another one is x2 which is in this direction. So we have to find the equation of elastic curve in term of v1 and v2, and at this end we have to find the deflection which is vc. So you can see due to this loading the deflection curve will be like this one, so we will find this. So let's start with the solution. So as we know that equation of elastic curve, we have this equation which is d square v over dx square v, where v is deflection in y direction and x is the coordinate, that is equal to m into x. So we will find the moment equation. So for that we have to find the reaction force at point B and C. So due to this loading, the deflection will be like this one. So we will have a reaction force at B is RB, and there will be a reaction force which is RA. So we will find this. So if we remove this support, so there will be a reaction force which is RA, and here you will having a reaction force which is RB. So RA and RB can be found by using the first equilibrium condition is sum of all moment about point B is equal to 0, and taking the counterclockwise moment as positive. So first moment is RA into perpendicular distance is this L, and it is producing counterclockwise, so it will be positive. The second moment is external moment which is m0, so it will be negative. So I will write from here RA into perpendicular distance is L minus m0 is equal to 0. So we will get RA is equal to m0 over L. Now you can find RB by using another equilibrium condition, that sum of all forces along y direction is taken as 0 and force upward is positive. So RA plus RB is equal to 0. So RA is again m0 over L, and since this is downward, so it will be negative, plus RB is equal to 0. So from here you will get reaction force at point B is equal to m0 over L. Now we have this reaction force. So what we will do is that we will find the equation of moment for coordinate x1. So for x1, so you can see x1 is there. So if you cut the beam along x1 coordinate and you draw the free body diagram, so it will be like this one. Let this is the x1 distance, where you have RA which is m0 over L. When you cut it, so there will be a shear force V, clear, and there will be a moment, and this moment, let this point is point 1 and this moment is m1 of x. So you can find this moment by using equation that sum of all moment about point 1 is equal to 0, and taking the counterclockwise moment as positive. So you can see one force is m1 by L and perpendicular distance is x1, and it is producing counterclockwise, so it will be positive. The other one is also m1 of x which is positive, so their sum must be equal to 0. So m0 over L into x1 plus m1 of x is equal to 0. So you will get m1 of x will be equal to minus m0 over L into x1. So this is the moment equation for coordinate x1. Clear? Now for x2, for coordinate x2, which is this one. Clear? So when you cut the beam over here, so and you draw the free body diagram, so you can see you have a moment at this point which is m0, and when you cut it you will be having shear force and you will be having a reaction moment. Let this is your point 2, and this reaction moment is m2 of x. So by using equilibrium condition, sum of all moment about point 2 is equal to 0 and taking the counterclockwise moment as positive. So one moment is this one, which is m2, and that is clockwise, it will be negative, and the second one is minus m2x because this is also negative. So minus m naught minus m2 of x is equal to 0. So it means that m2 of x is equal to minus m naught, and this is the equation of moment for coordinate x2. Now we'll move and we will find the equation of elastic curve. So by using equation of slope and elastic curve for x1, for coordinate x1, the equation will be ei into dv1 square over dx1 square is equal to m1 of x, and m1 of x is minus m naught into x1 divided by L. So if you integrate it once time, so you will get ei into dv1 over dx1 will be equal to minus m naught x1 square over 2L plus C1. Again integrate it to get the equation of deflection. Okay, so we will get V1 is equal to EI into V1 is equal to minus m naught x1 cube over 6L plus C1 x1 plus C2. Okay, from this equation of slope, if you divide both sides by EI, so you will get, from here you will get dv1 over dx1 is equal to 1 over EI into minus m naught x1 square over 2L plus C1. Let this is your equation number 1, and if you divide this equation by EI on both sides, so you will get V1, which is deflection at point due to x1. So it will be equal to 1 over EI into minus m naught x1 cube over 6L plus C1 x1 plus C2. That this is your equation number 2. Now for coordinate x2, I will write for coordinate x2 we will have EI into dv2 square or dx2 square is equal to m2 of x, which is minus m naught. So integrate it, we will get the equation of slope, which is EI E into I dv2 over dx2 is equal to minus m naught into x2 plus C1 C3. Okay, now again integrate this equation, again integrate, you will get EI into V2 is equal to minus m naught x2 square over 2 plus C3 of x2 plus C4. Okay, so if you divide this equation by EI on both sides, so you will get dv2 over dx2 is equal to 1 over EI into minus m naught x2 plus C3. Let this is your, this equation is your equation number 3. And if you divide this on both sides by EI, so you will get V2 is equal to 1 over ei into minus m naught x2 square over 2 plus c3 of x2 plus c4, and let this is your equation number 4. Now you can see that we have 4 equation. 1, this is equation 1, this is equation 1, this is equation number 2, this is equation 3, and equation 4. So we have 4 unknown constants c1, c2, and c3. So we will apply boundary condition in order to find this. So boundary conditions, first boundary condition is that at x1 is equal to 0, x1 is equal to 0, we have deflection v1 is equal to 0. So put it in equation 2, because equation 2 is this one, which is for v1, equation 2. So I will also show you at x1 is equal to 0, we have deflection here, v1 is equal to 0, because you can see this is the support. So we will put it in equation number 2. So when you put x1 is equal to 0, so this term will be 0, this term will be 0, and v1 is also 0. So we will left with c2. So it means that c2 will be equal to 0. Now we will use another boundary condition, that is at x1 is equal to L, we have v1 is equal to 0. So again you have to put in equation 2. So let me show you at here, you can see x1 is equal to L. So here v1 is also 0 because there is support. So you can just put it in equation number 2. So we have 0 is equal to 1 over ei, and we will have minus m naught L cube over 6L, okay, plus C1L, and C2 is equal to 0, so it will be. So from here you will get C1 will be equal to m naught into L over 6. So you have C1 and C2. So we will find C3 and C4 as well. So for that we will go to the boundary condition for x2. So first boundary condition is that at x is equal to L by 2, we have v2 is equal to 0. So you have to put in equation number 4. So this is your equation number 4, and I will show you the, here you can see you have x2 is equal to L by 2, and here we will have a deflection v2 is equal to 0 because this is a support. So when you put it in this equation, so you have v2 is equal to 0 is equal to 1 over ei n minus m naught into L by 2 whole square divided by 2 plus C3 into L by 2 plus C4, which is not known, is equal to 0. So again, if you simplify it, you will get 0 is equal to m naught L square over 8 plus C3 into L by 2 plus C4. So let this is your equation number 5. Now what we will do is that we will use another boundary condition, and that boundary condition is continuity equation. We will use continuity equation or continuity condition. What continuity condition says that at x1 is equal to L or x2 is equal to L by 2, we have dv1 over dx1 slope at 1 is equal to minus dv2 over dx2. So I will show you here, this is the point here at x1 is equal to L and x2 is equal to L by 2. So here we have slope which is dv1 over dx1 will be equal to minus dv2 over dx2, because x1 is taken in this direction and x2 is taken in this direction. So slope at these points will be same but will be in negative direction, or that will be is equal to minus dv2 or dvx2. Okay, so you can have equation of dv1 over dv2, which is equation number 1, and dv2 over dx2, which is your equation number 3. Where is equation number 3? So this is your equation number 3. So you have to put x1 is equal to, I will show you, you have to put x1 is equal to L in this equation. Clear? And you have to put x2 is equal to L by 2 in this equation. And you have to equate them, but with a negative sign with this. So I will do that. So dv1 over dx1 at x1 is equal to minus m naught. Okay, we'll choose marker. Minus m naught into L square over 2L plus m naught into L over 6 is equal to minus m naught into L by 2 plus C3. So when you solve this, you will get C3 is equal to 5 m naught into L by 6. Now put the value of C3 in equation number 5. So put C3 is equal to 5 m naught L over 6 in equation number 5. This is equation number 5. So when you put it here, you will get C4. Kindly put it and get, you will get 7 m naught L square over 24. Now you have C1, C2 and C3, C4 as well. So you can put in equation number 2 and equation number 4 in order to get the deflection at point due to x1 and deflection due to x2. So you can just put C1 and C2 in this equation. I will putting C1 and C2 in equation number 2. You will get V1 is equal to m naught over 6 EI. This is the simplified form. When you put the value and you simplify, you will get this one. So this is the, now put C2 and C3 and C4 in equation number 4. So when you put it, you will get V2 is equal to m naught over 24 EI. This is the final. I've already solved this, so this will be the final expression. You have to do a little bit by yourself so that you have a clear understanding. Okay, so this is these are the V1 and V2 in term of x1 and V2 in term of x2. So this is the first part. So in part B, we have been asked to find VC, deflection at point C. So you can see for deflection at point C, this is the point where x2 is equal to 0. So you can put x2 is equal to 0 in this, put x2 is equal to 0 in this equation. So when you put x is equal to 0, so you will have V2 will be equal to, this term will be 0, this term will be 0, and we will left with minus 7 m naught L square over 24 EI. Okay, so minus m naught L square, and there is a 7, minus 7 m naught L square over 24 EI. So negative sign means that the deflection is downward. Okay, so this was all about problem 12.17. I hope you have enjoyed this video and you have learned it as well. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.